Okay, let's talk about reactance. Reactance basically means resistance in DC. Okay, same meaning. Okay, but of course the physics and the source of that resistance is different. Okay, I think you remember for capacitor, when we are charging the capacitor, okay, the first electron coming in is very easy. Okay, but when the second one try to come in, okay, this is the driving force from the battery we're going to charge, and the force between them, there will be some electrostatic force. They are repelling each other, am I right? Because they are the same type of charge, positive repel to positive and negative repel to negative. So it is electrostatic force, okay, and they are repelling. Okay, they are repelling to each other. So this repelling force has a resistance. Okay, that causes the resistance of the new charge moving in or slow down the current. Okay, and how does this work in AC? Okay, I think in the class we talk about this one. I got a small bus. We use analogy small bus and big bus. Okay, for the big bus, that means we got bigger capacitor. Okay, for bigger capacitor, okay, bigger bus, C1, C2, okay, and when C1 is larger than C2, for the people to move in or the charge to move in is easier than C2, am I right? Okay, so what does that mean? That means when the capacitor is bigger, like the bus is bigger, and it's easier to move in, and that means the reactance is smaller. Okay, so that's the idea. And then how about the frequency? AC, we got frequency, am I right? So talk about the frequency. When the AC's frequency is higher, so we ask people move in, move out fastly or constantly, more often, okay? And then the bus will be mainly in empty, have more chance for empty, okay, because it move in, move out quickly, okay, and that means it's easier to get in and easier to get out. So for the capacitance is smaller as well. It's easier to get in, easier to get out, so the resistance is smaller. So we say reactance X, the symbol for reactance, okay, and the unit is like ohms, same like resistance, and it's inverse proportional to omega and the capacitance. Okay, so we can write that formula into this one, equal, okay, equal, directly inverse, okay, proportional to that one, omega, and then you can times 2 pi, become 2 pi f become omega. So this is the idea of reactance in capacitor.